Today, we're digging into something that honestly feels like it changed the world overnight: artificial intelligence. We're going to break down the blueprint for how modern AI is actually being built and used, really getting into the core of what's going on. So let's just get right to it. The question pretty much everyone is asking is, what happened? I mean, for years, AI was this kind of niche, interesting thing. And then boom, all of a sudden tools like ChatGPT show up and they can write and code and create in ways that just feel like a quantum leap. How on earth did we get here so fast?
Well, the answer, if you boil it all down, is one single powerful word: scale. For a long time, the AI community had this theory that if you just made the models bigger, gave them way more data, and threw more powerful computers at them, they get better. But what nobody saw coming was how much better. The jump in what they could actually do just from scaling up, it shocked pretty much everyone.
Okay, so if scale is the magic ingredient, how do we suddenly unlock it? Well, it all comes down to a really fundamental change in how we teach these AI models to learn in the first place. Think about the old way, which was called supervision. It was a total grind, a huge bottleneck. It meant you needed actual humans to manually label every single piece of data. So if you wanted to teach a model what a cat is, you'd have to feed it millions of photos where someone had painstakingly drawn a box and typed cat. It was slow and just insanely expensive. But the new way, self-supervision, it completely changed the game. It lets a model learn from raw, unlabeled stuff, like, the entire internet.
With self-supervision, the data basically labels itself. It's like a giant game of fill in the blank. The model sees a sentence like, "The grass is blank," and it learns to predict the word green. The sentence itself provides the puzzle, and the next word provides the answer. Now imagine doing that not once, but trillions of times across all the books and websites ever written. That's how these language models got so powerful.
So once that data labeling bottleneck was gone, it was like a dam broke. And what came rushing out were these massive foundation models. These things aren't one-trick ponies. They're not trained for just one specific job. They are these huge, general-purpose AI engines that you can then adapt to do almost anything you can think of. And this new reality, where we have these incredibly powerful, pre-built models just sitting there ready to be used, well, it has given birth to a whole new discipline: AI engineering.
So what is AI engineering? Honestly, it's a complete flip of the script. The old way was spending months, maybe years, and millions of dollars to build a new model from the ground up. AI engineers, they take these massive, ready-made foundation models and figure out clever ways to adapt them to solve their specific problem.
This is a huge shift in focus. Traditional machine learning engineering was all about the slow, hard work of building your own car from scratch, piece by piece. AI engineering is more like being given a Formula One engine, and your job is to tune it perfectly for the race you want to win. The tools are different now. We're talking about things like prompt engineering, which is basically the art of giving the AI the right instructions, or RAG, which helps ground the model in your specific data, and fine-tuning, which is like giving that general model a specialized crash course for a very specific job. And you better believe the business world noticed. I mean, just look at this chart. The number of top companies talking about AI on their earnings calls just went vertical. This isn't just buzz. This is real money, real strategy. AI went from a research paper topic to a boardroom priority almost overnight. And it wasn't just the suits in the boardroom. The people who actually build this stuff, the developers, went absolutely wild. Open source AI projects started getting popular on GitHub faster than legendary foundational tools like React. That shows you this is a massive grassroots movement. The barrier to entry just dropped and everybody wants to build. All right, so the money's flowing, the hype is real, the developers are excited, but what are people actually doing with all this? What can it really do today?
If you look at where the action is, a few big categories really pop out. Coding is the biggest slice of the pie right now, by far. Which makes sense, right? The first people to use a new tool are often the tool makers themselves, solving their own problems. But right behind that, you see a ton of work in creative tools, chatbots, and automating all sorts of business workflows.
Let's zoom in on coding, because it's way beyond simple autocomplete now. GitHub Copilot, which basically acts like a pair programmer, crossed $100 million in revenue in just 2 years. That's insane. And now there are tools that can literally look at a screenshot of a website and write the code to build it. It is fundamentally changing how software gets made. Then you've got the creative world, which has been completely turned upside down. You have tools like Midjourney that can whip up stunning photorealistic images from just a sentence. Adobe is building AI right into Photoshop, and startups like Pika are letting you create video out of thin air. For a business, this is a game changer. Imagine generating 1,000 different versions of an ad, each one perfectly tailored for a different city or a different season. And of course, there's writing and just dealing with information overload. AI can summarize that hour-long meeting you missed into 5 perfect bullet points. And the data here is just stunning. Get this. A recent MIT study had professionals use ChatGPT for writing tasks. Not only did they finish 40% faster, but the quality of their work actually went up by 18%. Think about that. Faster and better. That's a massive productivity unlock. Okay, so we see what's possible. If you're thinking about actually using this stuff, how do you do it in a smart, strategic way? You can't just dive in head first. A really good way to think about it is this crawl, walk, run framework. You start in the crawl phase. Here, the AI is a background assistant, like an intern making suggestions. A human is always in control. Then you move to walk. The AI can start interacting directly with your own team on internal, low-risk tasks. And only when you know it's proven and reliable do you run, letting it automate bigger things, maybe even interact directly with your customers. But here's a super important piece of wisdom from people who are actually building this stuff. Getting a cool AI demo to work, that's the easy part. That's going from 0 to 60%. The real challenge, the deep, hard engineering work, is getting from that promising demo to a 99% reliable product that people can actually trust. That last 40%, that's where the real engineering happens. And all of this leaves us with a pretty mind-bending thought to end on. Right now, AI is one of the best tools we have for building the next generation of AI. It's helping us write its own code. So the question is, what happens when that feedback loop gets faster? When AI starts improving AI faster and faster and faster?